Welcome to lesson 6. Today we are starting geometric sequences, and today we'll be doing what are geometric sequences, which are also known as geometric progressions. In short, we say GP. So what are they? And then we will also cover the formula for the nth term. The formula for the nth term. It's fairly similar to what we've already done with arithmetic sequences. There's only a slight difference, that's all. Let's get started. So, the difference between APs and GPs. We've just finished looking at arithmetic sequences. And in arithmetic sequences, we add or subtract a common difference between consecutive terms. For example, 2, 4, 6, 8. We can see clearly that we are adding 2. Every single term is 2 plus the previous term. And over here, we are subtracting 3. Every term is the previous term minus 3. Now in a geometric sequence, it's still a sequence of numbers where each term after the first is found by multiplying the previous term by a fixed number. And that's really the difference, right? In arithmetic progression, we add or subtract. In the geometric sequence, we multiply or divide. That's it. Everything else is almost the same. Obviously, the formula is slightly different, but in terms of the type of questions that'll come up and so on, and just generally the topic itself, it's fairly similar. So for example, if you have a geometric sequence like the one on the screen, 2, 4, 8, 16, 32, clearly we are multiplying the previous number by 2 to get the next number. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32, and so on. This pattern will continue. Now, this number we are multiplying by has a special name. So we are multiplying by 2, right? This has a special name. Like, you know how when we're adding 2 in arithmetic sequences, we call that the common difference? Well, in geometric progressions, right, the number we are multiplying by is called the common ratio. And we use the variable r for this. So in the above example, the common ratio is r is equal to 2. We're multiplying by 2, so r is 2. Now, something I just like to point out, the difference between multiplying and dividing. Dividing and multiplying are related operations. So if you guys remember your fractional operations, dividing by 3 over 4 is the same as multiplying by the reciprocal of 3 over 4, which is 4 over 3. You just flip it and you multiply. Remember in fractions, if you had to divide 2 fractions, you flip the second fraction and then you multiply. So I guess the idea is, if you flip it, you can just multiply it. So dividing by 2 is the same as multiplying by a half. You just flip the 2, 1 over 2. And if for example, you have to divide by 3 over 4, in a geometric progression, if the numbers were dividing by 3 over 4, we don't say it's dividing by 3 over 4. We say it is multiplying by 4 over 3. So, for the sake of simplicity, and just so that the formula stays the same, we always say that GP, the numbers are multiplying by the constant ratio, by the common ratio. We don't say dividing. So sometimes the sequence will look something like 1, half, a fourth, and we know clearly that it is. It's dividing, like it's going half. But we don't say. We'd say it is multiplying by half. We don't say it's dividing by 2, right? We say it is multiplying the previous term by half. Just something for you to keep in mind. We will always say multiplying. All right. Dividing by 2 is the same as multiplying by half. Alright, so examples of GPs. 1, 2, 4, 8. This is multiplying by 2. And the next example is 200, negative 150, negative 25. Now over here, this might look really weird, and you might be thinking, well, hang on a second, that's a weird pattern. Is that really anything? Well, yes, it is. It's actually multiplying by half. And I want you to keep this in mind. Anytime a sequence is alternating signs, positive, negative, in 99% of cases it's going to be geometric progression, and r will be negative. Okay, when r is negative, it is alternating signs. Okay, and the negative doesn't make the sequence go down. The only thing a negative r does is to alternate the sign. The thing that makes this go down, make the sequence go down, is that it is a fraction less than 1. Alright, move on. 4, 10, 25, 62.5, multiplying by 2.5. So these numbers don't really look familiar. Just goes to show you can't trust it. Alright, there's another interesting one. If the numbers are alternating between surds and non-surds, then R is going to have a surd component, right? 2 multiplied by root 3 is 2 root 3. If you multiply by 2 root 3 again, 2 root 3 times root 3, the roots will cancel out. You'll have 2 times 3, which is 6, and so on. Over here, it's clearly multiplying by x. It's going up by x, x squared, x cubed. Okay, this one, it's going down, so it's a fraction less than 1, obviously. And the numbers don't look familiar, but yeah, it is multiplying by 3/4. The common ratio formula. Now, a geometric sequence, by definition, is a sequence where there is a common ratio between terms. So algebraically, if we were to write this is how we would write it. Ratio is equal to the nth term divided by the n minus 1th term. In other words, you can get any term and divide it by the term just before it, and you will get the common ratio. Now, the important thing is it has to be consecutive terms, and the later term, or the later term, is going to be on top. It's the third term over the second term, or the 100th term over the 99th term, right? 50th term divided by the 49th term, and you will get R. That is the common ratio. So we just divide any term of a geometric sequence by the term just before it, and that will give us the common ratio. For example, second term over the first term. For example, if that was the ratio, if that was the sequence, we could do 4 divided by 2, 8 divided by 4, 16 divided by 8, 32 divided by 16. It doesn't matter which one we would do, the common ratio is clearly 2. And in geometric progression, that's the idea. You could divide any 2 consecutive terms, right, and you'll get the common ratio. And make sure the later term is on top and the small terms on the bottom. In other words, you do 16 divided by 8, not 8 divided by 16, right? Alright, so testing of sequence is a GP. This is slightly different, but how do we test if a sequence is GP? Like over here, we knew the sequence was a GP, and we were finding the common ratio, right? In that example there, 2, 4, 8, 16, 32. We know, we're telling us that that sequence is GP. But what about if we don't know? What do we do? Well, we can use an application of the common ratio formula, and what we'll do is we'll check. We'll say, third term divided by the second term, is that the same as the second term divided by the first term? In most cases, this will be enough. But sometimes you'll have to do it for every single number, if there's like 4 or 5 numbers. And we'll always write a statement. We say, if this pattern continues, then this sequence is a GP. For example, let's look at 3, 9, 27. There's only 3 numbers here. So we need to check, well, which is the first term, which is the second term, which is the third term. So the formula is the third term divided by the second term is equal to the second term divided by the first term. So let's say this is the first term, this is the second term, this is the third term. Right, so we need to do 9 over 3, and we need to check if that's equal to 27 over 9. So we need to check whether 27 over 9 is equal to 9 over 3. 27 over 9 is 3. 9 over 3 is 3. Well, hey, it does equal, therefore, that is a geometric progression. Alright, so a bit of a quiz. Please pause the video and practice applying the common ratio formula, please. And just pause the video now. And let's see. Right, first question, the answer to the first question. R is 2, 2/3, half, -1. And remember, a sequence where the positive and the negative numbers are alternating has a ratio of negative, has to have a negative ratio. -2x, p, -1/4, or -0.25. Alright, let's move on. This is a harder common ratio question. Find the value of x such that 3, x plus 4, and x plus 10 form an arithmetic sequence. I know this video isn't really about arithmetic sequences, but just, I hope this acts as a revision and just to consolidate the difference between the APs and GPs. So let's say you have three numbers, 3, x plus 4, and x plus 10. How would we find the value of x such that those three numbers form an arithmetic sequence? Well, how do we test for an arithmetic sequence? We do T3 minus T2, the third term minus the second term has to equal the second term minus the first term. So just substitute it in. Third term was x plus 10 minus the second term x plus 4, and we have to make it equal to the second term minus the first term, which is x plus 4 minus 3. Simplify, you get x equal to 5. Easy. Alright, but how about if we wanted to make it a geometric sequence? Then we do the third term divided by the second term has to equal the second term divided by the first term. Okay, and again we substitute it in. Okay, that's a fairly standard, I guess. At this stage in your maths career, so to speak, this should be a fairly standard algebraic equation for you to solve. Cross multiply, you get that. 3x plus 30 is equal to, x squared plus 8x plus 16. And collect like terms, factorize, and it has two different answers, x is equal to 2 or x is equal to negative 7. Either of these two values will make sure that these two numbers will give a geometric progression. Alright, let's derive the formula for a geometric progression's nth term. So let's say the first term of some random geometric progression is a. The first term is a. And let's call the common ratio of this geometric progression r. So we are multiplying the previous number by r to get the next number. Okay, so we have a geometric sequence, a random one. Could be any. The first term is a, and we're multiplying each sequence by r. So what is the first term? Well, a, obviously. What is the second term? We have to multiply a by r. So ar, a times r. The second term has ar. Remember, we're trying to find a pattern here, so just keep that in mind. The pattern between the number of the second term and ar. Just keep that in mind. So what is the third term? Well, the third term is ar, the second term, multiplied by r again. And that will give us ar squared. The third term is an ar to the power of 2, and I've color-coded it. Should be a dead giveaway, but let's look at the fourth term anyway. The fourth term will be ar squared, which is the third term, multiplied by r again, the common ratio, because it's increasing by a multiple of r every single term, right? This gives us ar cubed. So fourth term, ar cubed, 4, 3, 3, 2, 2, 1. Hopefully that gives it away. So what is the relationship between the position of the term and the coefficient of r? Well, the coefficient of r is 1 less than the term number. So what would the nth term be? Formula for the nth term in any geometric progression. Well, the nth term will be ar to the power of n minus 1. 1 less than that. 4, 3. 3 is 1 less than 4. 2 is 1 less than 3. And n minus 1 is 1 less than n. And so that is the formula. The formula for the nth term of a geometric progression is given by the first term multiplied by the common ratio to the power of n minus 1. Now, T of n is the value of the nth term, a is the first term, r is the common ratio, n is the term number within the sequence. Now, make sure you don't confuse n and tn, right? This is the nth term, and n is the term number. This is the value of the term. So, for example, in 2, 4, 8, 16, 8, right? This is the third sequence. N is equal to 3. This is the third number in the sequence, right? But what is the third number? It's 8. T of n, the nth term, and the third term is 8. 8 is the third term, right? The number within the term is 3. Alright, so let's look at an example question. Please try and pause and see if you can give the question a go yourself. It does help a lot if you can just think your way through it. You just understand it a lot better rather than watching someone else do maths. It's always better for you to do maths yourself. Alright, so for the following sequence, 4, 8, 16, 32, show that the sequence is geometric. Well, how do we show that? We do T3 over T2 has to equal to T2 over T1. And 8 over 4 is equal to 16 over 8, which is equal to 32 over 16, and they're all equal to 2. Assuming this pattern continues, common ratio is equal to 2, therefore it is a geometric progression. Now this sentence is It's a good sentence to memorize, I guess, because you can't be sure that the next number, could be like, I don't know, 31 or something, and then it wouldn't be a geometric sequence. But we're going to assume that this pattern continues. That ... means it should continue in the same vein, right? We hope it does. So just to be sure, we write this sentence, assuming this pattern continues. And also, if this comes up in an exam, make sure you test every single one of these numbers. It's possible that the first 3 terms will follow the geometric progression sequence, but the 4th term will not. It's possible. So we always check all of them, just in case. Alright, so find the general term, AR to the n minus 1. Well, we know r is 2. We know the first term is 4. So 4 times 2 to the power of n minus 1. A times r to the n minus 1. I mean, you could simplify that a bit more, I guess. Because 4 is the power is 2 squared. And, don't worry about it. Just keep it simple for now, okay? A r to the n minus 1. Alright, so see. Find the 10th term. We know n has to equal to 10. We're trying to find the 10th term. So T10 is equal to, we sub it in. We know n is 10. We sub the 10 in. Put in a calculator. Simplify. 2048 is the answer. Alright, let's look at example 2 when n is missing. So the questions I'm doing, I'm showing you different types of questions. So example 1 was where the nth term is missing, or they're asking us to find 50th term, 100th term, whatever. Now in this example is when n is missing. We know the term, we know the value of the term, we just don't know which term it is in the sequence. So how many terms are there? Or in other words, 3072, what term is that within the sequence? Well, we know A is 3, and we know R is 2, because 6 divided by 3 is 2, 12 divided by 6 is 2. So AR to the n minus 1, the nth term is 3072. Now, let's write down the formula for the nth term, right? The nth term formula is 3 times 2 to the power of n minus 1. AR to the n minus 1, and we know that's equal to 3072. And we use the A and R values. Now we're just going to solve. So 1020, divide both sides by 3. 1024 is equal to 2 to the power of n minus 1. Now note here, if you haven't done logs, you won't know how to solve this except by guess and check. So feel free to use guess and check if you haven't done logs yet. If you have done logs and you've forgotten, I guess this might be a quick revision. And this is going to pop up a lot. Basically, anytime there is a variable, a letter, inside a power. Okay, so that's 2 to the power of n minus 1. If it's in a power, you need to use logs. Just log both sides. So just add in the log to both sides. And if you remember the properties of log, that n minus 1 we can actually bring out to the front, which is really the key. We don't want it in the power because we can't solve it if it's in the power. It's very hard. Unless you use guess and check or something, and the answer is, it just happens to be a perfect number. But anyway, like as in not a decimal or a fraction or something. Anyway, so n minus 1 comes to the front. Now we just manipulate as per normal. The log 2 divides over there. So like that. Now we add 1 to this side, put in the calculator, and you get the answer of n is equal to 11. Easy. Logs is really easy. Alright, so example 3, when A and R are missing. So the next archetype or the next type of question that you'll find is where A and R are missing. We've done the question where n is missing. We've done a question where the nth term is missing. Now we're doing a question where A and R are missing. So in a geometric sequence, the second term is -6 and the fifth term is 162. Find A and R and hence the nth term. Alright, so let's just write down the information we have. The second term is -6. So T2, second term is -6. T2 is AR to the n minus 1, but the second term, n minus 2 minus 1 is 1. So we're just going to write AR to the power of 1. AR is equal to -6. And we've also been given this information. The fifth term is 162. So the fifth term will be AR to the 4, right? AR to the 4 is equal to 162. And hey, that looks like a simultaneous equation type question. So divide one by the other. AR, the fifth term over the second term. A's will cross off. The R4 will become R cubed. R cubed is equal to -27. R is equal to -3. So we've got we've got R. Now we substitute R back into that or that. It's up to you. I chose the second term. And you get A. So you get A and R. We found A and R. What is the nth term? Well, we'll just write it down easy. Nth term is 2 times -3 to the power of n minus 1. All you need to find the nth term is a and r. We found a and r. So sub it in. There we go, done. Alright, example 4, inequality type question. Find the first term of the geometric sequence 6 square root 2, 12, 12 square root 2, which exceeds 1400. Before we go further, you should have noted that it's alternating between surds and non-surds. So r is going to have a square root. I did point this out earlier, hopefully you haven't forgotten. So, which exceeds 1400. Alright, so a, we know, is 6. Well, r, which is 6 root 2 divided by 6, you get root 2, easy. We have, it shouldn't be d, that should be r. That's okay, don't worry. So a and r, we found a and r. Nth term is like that. And we need to find the first term, which is more than 1400. So in other words, set up the inequality. Nth term has to be more than 1400. Divide both sides by 6. Log of both sides. Or you can use guess and check. Take log of both sides. Divide this log root 2 over to there. Add n minus 1 over there. And I just did it on the calculator. So I did the right hand side on the calculator. Log 233 and a third divided by log root 2 gives us 15.73. Well, now we add 1 to that. And 16 has to be more, n has to be more than 16. Therefore, we know the first term is the 17th term, which is 1536. You could check the 16th term and you will find that it's less than 1400. Alright, that's it. Good luck with the homework sheet.